We can get started now, finally, after some technical difficulties. I figured with a room of tech people, we're able to solve them. Apparently, we weren't capable of solving them so far, but now we can get started. For those who haven't met yet, my name is Duncan Epping. I'm the Chief Technologist at the moment, working for VMware or Broadcom, or whatever kind of situation we're in. We're not sure yet. We'll find that out probably next Monday. As the slide says, I'm going to be talking about vSAN. Has anyone used vSAN so far? By show of hands. Okay. Everyone familiar with how ESA works, how OSA works? Yeah, some of you are, some of you are not. So what I'll be doing today is I'll be doing a brief introduction in terms of what it looks like, why we did this in the first place. And then what I'll be doing next is showing some of the capabilities that we introduced recently up in 8.0, update 1 and update 2. And then I'll also talk a bit about what we're planning for the future. So what's coming up in the upcoming 6 to 12 months, which is basically our roadmap more or less that we have planned at the moment. Now, if you look at these numbers up on the screen, this is a rough estimation based on the telemetry data that we have from about 30,000 customers at the moment. There's about 10,000 customers that are reporting back to VMware at the moment in terms of what their estate looks like. And some of these numbers are quite significant. If you look at one of our largest customers, is doing close to an exabyte worth of vSAN storage on their estate. Of course, that's not in a single cluster. We're talking about, maybe even hundreds of clusters in that particular case. But it's a huge amount of capacity that they're running. In terms of the total number of VMs running on top of vSAN, we're talking about millions. So we're not talking about, a small storage vendor in this particular case. We're actually talking about a solution which has been adopted by thousands of customers, running millions of virtual machines across hundreds of thousands of hosts in this particular case. And when you look at the type of customers, because that's typically the question that comes next, it's all over the place. We've got customers with 3 hosts using vSAN. And obviously, we've got customers with hundreds or thousands of hosts using vSAN as well. And then ranging anywhere from local mom and pop shops all the way down to, for instance, submarines or large banks, financial institutions, whatever you name it. Some of the largest stock exchanges, for instance, run on vSAN as well. So it's all over the place in terms of verticals that are using vSAN. Now, of course, the question typically comes is why are customers using vSAN? It is primarily because of the ease of use. If you look at vSAN, for instance, itself, and what I'm going to show you here is how we create a stretch cluster configuration. Now, if anyone has created a stretch cluster configuration at some point in time, using, for instance, Dell EMC vPlex, or maybe NetApp Metro clustering, or SVC, or whatever it is, you know how complex it can be to set up environments like that. With vSAN, everything is done through the vCenter interface. So you do everything on the cluster level. So if you know how to enable HA and DRS, you also know how to enable vSAN. There's a couple of things that are important that you will need to do is, first of all, you need to claim local disks. Every host, in our particular case, because it's an HCI-based solution, has local disks. Or in the case of vSAN, ESA NVMe devices. We grab those NVMe devices, and then you can start forming a cluster. Because this is a stretch cluster, of course, we need to form sites. So in this case, what we're doing is we're identifying which hosts belong to which logical site. After we've done that, we can select the witness host. After the witness host has been selected, we can click next, finish, and the cluster itself is going to be created from a storage perspective. So on the back end, what now happens is we're going to grab all of those disks. All of those disks in each host will form a storage pool. All of those storage pools combined will form a data store itself, and that data store is now stretched across multiple locations. And I didn't speed up this video, just to be clear. So it literally takes anywhere between 5 minutes if you're slow with clicking to maybe down to 2 or 3 minutes to set up a stretch cluster configuration. Now, after you've done that, the next, probably most important thing that when it comes to vSAN needs to happen, and that is creating a policy. Because when you look at virtual machines, or you deploy virtual machines, or maybe containerized applications, whatever it is, maybe a file share, with vSAN, everything happens through policy. Within a policy, you get to define what needs to happen to the data. So in this case, because we have a stretched cluster, I can say, this is a stretched environment, and I want to have RAID 5 protection within each location. So I get to set that on a policy level. Of course, I'm just creating a single policy here, but normally we create multiple policies, right? Depending on what you're deploying, you select the policy that you need. That could be protection across locations, that could be protection within a location. That is the power of vSAN. Everything goes through policy-based management, and depending on what you specified in a policy, vSAN will follow. So if the policy states spread the data across sites, vSAN will automatically spread the data across sites. If for whatever reason the requirements of your application changes, you don't pick up the VM and move the VM, you change the policy. When you change the policy, and the policy, for instance, states it no longer needs to be spread across sites, then the data is also going to change on the back end. So vSAN will say, okay, the policy now states it doesn't need to be spread across sites, it only needs to be contained in site A, and then automatically all the data will move to site A and will stay. So vSAN has those capabilities all built in within the platform. And like I said, through policy, you make all the changes that you need. So in my opinion, that is the true power of vSAN. Well, when we started building out vSAN, that was in 2013. Have people been using it since 2013, 2014, anyone? Yeah, it's a couple of folks here. So you started around 2013 was the beta, and then 2014 was the very first release. And when we started designing vSAN, the interesting thing is that most data centers look like this. So you would see a hard drive, you would see some flash capacity in some cases, majority of you were still using spindles. Then the average CPU only had 4 to 10 cores, which is, if you think about it now, relatively low. And then you would see typically 1 gig networking. Some of you were already, delving into the 10 gig networks, but we didn't see that too much yet. And then, of course, when you looked at the workloads, it was all virtual machine-based workloads. Of course, there were containers, but we didn't see those in VMware estates back then, just yet. You saw them within some of the Linux environment, but we didn't see that too much. And then, majority of workloads, of course, were all running on premises. If you look at today, what the world looks like today, for the majority of you will see that it looks completely different. First of all, from a hardware perspective, if you look at the CPUs, we don't have 4 to 10 cores, no. People go all the way up to 64 cores per socket. And then, secondly, from a capacity perspective, but also from a performance standpoint, most people are not using spindles anymore, unless they have a very specific use case. Most people end up buying flash, and there's multiple types of flash these days. It's not just a single type of flash as we had back in the day, but now we have multiple types of flash that we need to consider for. And then on top of that, of course, also from a networking perspective, majority of customers have already been using 10 gig for the longest time now, and are actually looking to move towards 25 gig networks, or maybe even all the way up to 100 gig networks. But that is still a minority when it comes to 100 gig networks because it's relatively expensive. And then, of course, last but not least, also all the workloads have changed over the years. You see people still, of course, deploying virtual machines, but they became, a bit bigger. And then we also see customers doing a lot with containers. And then where we deploy the workloads has also changed. It's not just on premises, but it's also within a cloud. That could be VMware Cloud on AWS. It could be an Azure VMware-based solution. It could be Google. It could be anything. That also means that from a vSAN perspective, the world has changed significantly. And that is the reason we actually introduced a new architecture. So far, the majority of you have probably been using vSAN, OSA as we refer to it today, the original storage architecture, which is what was introduced in 2014 or 2013 as the beta. What we've actually introduced now is a new platform, which is what we refer to as ESA. And I probably shouldn't say new platform, because it's still the same platform, but it's a different architecture within that platform. I'm going to go through some of the differences. But the important part here, first and foremost, is because someone's going to ask this question, I'm already running vSAN, can I upgrade from OSA to ESA? The answer is no. Unfortunately, that's not possible. The reason for it is straightforward. It's because 99.99% of all of our customers do not have the hardware that allows them to actually run ESA within the cluster today. That is the reason we do not have an upgrade scenario. I've met maybe 2 or 3 customers that actually have those capabilities, and they found a way around that in order for them to actually move from one platform to the other platform. If you're in that situation, I'm happy to have that conversation with you. Now, there's a couple of things that changed massively. I've already mentioned that we've seen these hardware shifts. So spindles and some flash to all flash, NVMe-based QLC or TLC. With vSAN ESA, we only support TLC at the moment, NVMe-based TLC. So no SAS connected, no SATA connected. That is one of the reasons the majority of you will probably not be able to upgrade, because most of you probably use some kind of NVMe front-end cache and then typically SAS or SATA connected capacity. So with ESA, we only support NVMe connected. Now, from a price standpoint, if you look at the price point today, there's not really a huge difference there. That used to be the case 3 or 4 years ago, but it's not no longer really the case anymore. The other interesting thing is that with ESA, it's a single tier solution. There's no caching layer and capacity layer from a physical perspective. With OSA, when you create a cluster, you need to select the caching disk and you need to select the capacity disks. That is no longer the case with ESA. It's a single tier. So all of the devices that are part of your host will both contribute to storage, capacity, as well as performance by default. That is something that we've implemented in the platform. There are a couple of other things that we wanted to work on. First and foremost, of course, is at least having a solution which is still easy to manage. So from a management perspective, nothing has really changed. Actually, it became a bit simpler because you no longer have a caching disk and a capacity disk. All disks just do the same thing. The second thing, of course, is that we wanted to make sure that we offer at least the same level of resiliency, but potentially even higher. So higher availability with the same cost. And the other thing, of course, from an efficiency perspective, when it comes to handling I/O, we wanted to make sure that we were more efficient with ESA than we were with OSA. So there are a couple of things that we introduced in the platform that allow for that as well. And then last but not least, something that a lot of you actually asked for is native scalable snapshots, meaning a snapshot that actually does work compared to vSphere snapshots or vSAN snapshots in the past from a performance perspective. So a snapshot where the performance doesn't degrade when you create 2 or 3 snapshots in a row. That is also something that we've implemented. And I've got a demo to actually show you how that works. Now, if you look at the OSA, and I'm just going to briefly run through this because I realize most of you have already implemented this in some shape or form. As I mentioned, you have these 2 layers there. You have that caching disk and you have that capacity disk. Now, in some cases, where a failure occurs, of course, when the caching disk, for whatever reason, dies, it also typically means that the capacity disks come unavailable. Also, when you have deduplication and compression enabled, if one of the devices failed, that whole disk would become unavailable. This, from a availability perspective, of course, wasn't optimal because it impacted a large portion of your capacity. With vSAN ESA, because we have that single tier and all devices have the exact same functionality and do the same thing from a task perspective, if a single device fails, there's no impact to any of the other devices in your storage pool because there's no caching disk. So there's no single point of failure anymore when you look at it from an architectural perspective. So that's probably one of the biggest changes in the platform in itself, and also from an operational perspective, it does make your life a bit easier when it comes to managing these systems. Well, there are a couple of other things that under the hood that we changed. Now, I don't expect you to fully dive deep into all the different layers that we've introduced, but there are a couple of things that may be important to understand. If you look at vSAN itself, and you look at all of the different components, when we introduced ESA, a lot of people were kind of worried about the fact that we introduced a whole new architecture, and they thought that it was a full new product. It actually is not a full new product. What we actually did is we looked at all of the different components that are part of vSAN, and we looked at the different components, the services that we could optimize that would provide us, the best efficiency from an I/O perspective. So one of the things, for instance, that we did is we introduced a new file system at the top of the layer, which helps us be more efficient in terms of handling I/O. So that is the block structure file system that we've introduced at the top. Now, block structure file systems have been around for ages. Those who do something with Linux, for instance, have seen block structure file systems popping up. The interesting thing with block structure file systems is that they were actually invented by one of the founders of VMware itself. So after 25 years, and he invented this 40 years, but after he founded VMware 25 years ago, we're now actually reusing his invention, which is quite interesting. And then the other thing that we've done is we've made some changes at the bottom layer So that from a tracking I/O perspective, we can also introduce things like, for instance, scalable snapshots. So the log structure file system, which was already part of vSAN itself with OSA, has also been updated for ESA specifically. So if you would go under the cover, there's actually a different module implemented for ESA than there is for OSA. But all the other components, so those who actually look at the components, things like CLOM, for instance, they're still there. So they're still the same components. So it's, let's say, 20% of the code base that has actually been changed to introduce ESA. Now, if you look at the different layers and you look at the way that I/O has been handled, and there are a couple of things which are significantly different when it comes to OSA versus ESA. As I mentioned, with OSA, you have that capacity layer, and they have that caching layer. And if you do an I/O will typically go to the caching layer first, and then we'll go to the capacity layer. Now, all the way at the bottom, I don't know if everyone can see it, but it says performance lag and it says capacity lag. And I'll show that in a demo later on as well. But this is more or less very similar to that caching layer and that capacity layer, but this has been implemented in software, so it's not a hardware capability. This is basically that log structure file system. And this log structure file system is what we refer to here as a durable log, and it actually coalesces all the I/O that a virtual machine is doing. So it collects all the I/O that a virtual machine is doing until we have a full stride write, so we can write efficiently to the capacity disks itself. And when we've collected that, we will actually do that full stride write. So that's why we have a log structure file system in place. So we collect the data itself until we have 512 kilobytes, and then we write it down. And there's a reason we actually use that 512 kilobytes, because from a block perspective, if you look at the devices that we're using, those TLC devices, but also later on potentially QLC when we support those, the system, at least from an architectural perspective, has already been prepared for that. When we support that, those devices are optimized for large writes. Those are not optimized for 512 bytes writes or 1 kilobyte blocks, for instance. Those are optimized for large blocks, and that's why we do large blocks as well. So we collect the data in memory and we store it on disk as well in the log structure file system. When we get a sufficient amount of data, we write it down to, in this particular case, RAID 6 configuration. Could be RAID 5, could be RAID 1 as well. The interesting thing here is that from a caching standpoint or coalescing standpoint, it's always stored in a RAID 1 configuration, which means that it doesn't matter anymore if you do RAID 5 or RAID 6 from a capacity perspective or RAID 1. All the data, when it's first being absorbed, is always going to be absorbed on a RAID 1 level, which means that from a performance perspective, you will get RAID 1 performance at the cost of RAID 5 from a capacity or RAID 6 standpoint. So compared to vSAN OSA, for instance, you will see that if you use something like RAID 6, there's a probably 30% or 40% performance increase when it comes to ESA compared to OSA, just because of this implementation. The other thing to mention is for people who are doing actually really large writes, because I had that question when I was presenting at Explore 3 weeks ago. When you're doing really large writes, we actually have a mechanism in place that identifies how large the I/O is, so we can also bypass that whole memory object and just write to capacity directly when the write is large enough. So we have that built in. It's a fairly smart system. And the nice thing is that as an administrator, you don't need to do anything about it. But there are a couple of other changes as well from an efficiency perspective. If you look at vSAN OSA and you look at data services like compression or encryption or something like checksumming, they all happen at the lowest level, which means that if a virtual machine does an I/O, it typically will go to multiple hosts. Each host individually will compress the data, it will checksum the data, or it will encrypt the data. So each host will do that individually. If you have 6 hosts in a cluster and you do RAID 6, that means that that action needs to happen 6 times. With vSAN ESA, we actually move all of the data services to the top, which means that if that virtual machine writes, we're first going to compress the data, checksum the data, encrypt the data, whatever you have enabled, and then the data will go down to the other hosts. Which means that instead of needing to do that 6 times on each individual host, we now only need to do it once on the source and not on all of the destination hosts. So this is where that efficiency comes into play. That also means that from a CPU consumption perspective for vSAN specifically, if you have the same workload, the exact same workload running on OSA versus ESA, you will see that ESA will consume much less CPU cycles as a result, if you are doing the exact same I/O. I've seen people doing benchmarks, and they are comparing the benchmarks with OSA versus ESA, and they say, hey, you know what? ESA is consuming a lot more CPU cycles. Yeah, that's because ESA is also doing 3 times more I/O. So if you're doing more I/O, of course, the results will be different. If you're doing the same, then you will see that ESA is much more efficient compared to OSA because of this implementation. The other nice thing, of course, is, I probably should have mentioned that, is because the data is compressed at the top, it also means that it will travel across the network compressed. So there's also a benefit from a bandwidth perspective, not just for a regular cluster, but for instance, also when you do a stretch cluster between 2 cities or a campus cluster, whatever it is, the bandwidth consumed between those sites will be less as a result because the data is compressed. There are, of course, a couple of other things that we've implemented, and I'm going to show a couple of demos as well that will show some of the power of the capabilities that we've implemented. As mentioned, one of the big differences is that you no longer have those disk groups anymore compared to OSA. So with OSA, you have to form those disk groups. With ESA, you get to form what we call storage groups. One of the functionalities that we have actually reintroduced is the automatic claiming of NVMe devices. And this can be quite useful. With OSA, particularly, if you added a disk or additional devices in one of your hosts, you actually had to go to the device, itself, or go to the disk group and claim those devices yourself. With ESA, that is no longer needed. ESA can manage that for you. So you can set it up in such a way that it will actually automatically claim all the devices that are added to the system automatically. So if someone walks into the data center, they add 5 NVMe devices, your vSAN data store will automatically grow with the capacity of those 5 NVMe devices. So you don't even need to touch the system in order for it to grow, which is very useful in my opinion. And again, when it comes to a storage pool, there is no single point of failure anymore because we no longer have that caching device. So that is also very beneficial in my opinion. From an availability perspective, we also introduced a couple of changes. One of the most interesting changes, in my opinion, is the adaptive RAID 5 mechanism. So one of the things that we've done is we've created a new RAID 5 scheme which actually automatically updates the way that the data is spread out based on the size of your cluster. So I probably should explain how that works because it's not as complex as it sounds. The way it works is the following. If you have, let's say, a 6-node cluster in this particular case, and you create a RAID 5 configuration for a virtual machine, that will by default be a 4+1 scheme, meaning 4 data blocks and 1 parity block. That is what the layout of the data will look like. And RAID 5 means that one host can disappear and the data will still be accessible. It's a failure tolerated block. Now, the nice thing about this mechanism is that if one host disappears, after 24 hours, vSAN is going to say, okay, you know what? If another host dies, my data is probably compromised, so I'm going to refactor my data from 4+1 automatically to 2+1. Which has the added benefit, if additional hosts end up disappearing, the data is still accessible in this particular scenario. That is the benefit of that adaptive RAID 5 scheme. It does that in a fully automated fashion for you. You don't need to do anything. And this happens within 24 hours. So if a host fails or you place a host in maintenance mode and it stays in maintenance mode or it has been failed for longer than 24 hours, this will automatically kick in. Of course, I created a demo just to show you what that looks like. We're not going to wait 24 hours because I only have 45 minutes. So I made a change from an advanced setting perspective. We have an advanced setting available where you can actually say, okay, make those changes after a minute. I wouldn't recommend changing it to a minute, but you can. You can, of course, also change it to 40 or 48 hours. For instance, if it takes HP or whoever it is a bit longer to bring you those new devices, you don't want to see those resyncs happening. So as you can see in this case, I have a virtual machine which has a RAID 5 configuration. This is the capacity lag, and this is, by the way, the performance lag. So you can see that in the UI as well. So for those already using vSAN, if you see multiple different types of components popping up, that's actually that new implementation. Now, we have 6 hosts in the cluster, and I'm going to place one host into maintenance mode. I change the advanced setting, so within a second, that RAID 5 configuration should now change to a RAID 1 or a RAID 5 configuration in a 2+1 scheme. So the host is in maintenance mode. I'm going to go back to RAID 5 now, to the virtual machine. And then you will see where we just had 4+1, it now has a 2+1 scheme with a RAID 0 in there as well. But it has changed that configuration based on the number of hosts within my cluster. Now, of course, if I take the host out of maintenance mode, or when the host has failed and it comes back for duty, that virtual machine is going to be reconfigured automatically as well within 24 hours. So you as an administrator don't need to touch it. Again, in my case, that happens within a second because I configured it that way. Normally it's 24 hours. If for whatever reason you feel it needs to be 48 hours, there's an advanced setting where you can change this. For most people, 24 hours is usually the sweet spot. But again, if you want to change it, you can change it. This has actually been implemented in vSAN ESA as a platform. So pretty straightforward. The other thing that we've implemented in the platform itself, and I think this could also be useful, is what we call auto policy-based management. Now, as I said, vSAN is all about policy-based management when it comes to creating a virtual machine, managing virtual machines, managing file shares, managing containers, etc. One of the biggest problems I've seen with customers is that they introduce new capabilities in their environment, but they forget to make changes to the policies that are already being used by virtual machines. So in this particular case, for instance, we have a 5-node cluster. In some cases, when you have a 5-node cluster and it becomes a 6-node cluster, you may want to change, for instance, the RAID 5 configuration or the RAID 1 configuration to RAID 6, simply because it adds availability to your virtual machines. And with the auto policy-based management capabilities, we can inform you about those changes. It doesn't just apply to adding nodes, it also applies to removing nodes from the cluster and also changing functionality. So if your normal cluster that was contained within a single site all of a sudden becomes a stretched cluster configuration, this capability can also inform you about that. And we've had customers actually in that situation where they forgot to make changes to that policy and those virtual machines weren't stretched while they should have been stretched, which is not fun when the first disaster occurs. You can imagine that when something goes wrong and your virtual machines weren't stretched and you expected them to be stretched, that all of a sudden they are all inaccessible. Let me show you what that looks like. So in this particular case, I have a 3-node cluster and I've got a virtual machine configured with a RAID 1 policy. So as you can see, it's at RAID 1, and we have, in this particular case, auto policy-based management already enabled. So that should pop up somewhere over here. There we go, auto policy-based management is enabled. So what we're going to do now is we're going to introduce additional hosts within the cluster. As soon as we take the host out of maintenance mode, and capacity has been contributed to the cluster itself, the vSAN health check is going to say, hey, instead of a 3-host cluster, you all of a sudden have a 5-host cluster. So that policy with RAID 1 may not make sense anymore for your virtual machines. Do you want to make changes to the policy? And then you can say, yes, apply those changes to the policy. So we have that capability within the platform. Now, as I said, that actually happens within the health check itself. So within the health check, there's going to be a check that pops up that says, you do not have optimal data store default policy anymore. You want to change it. In this case, of course, I'm going to change it, and it's going to change from RAID 1 to RAID 5. Now, the fact that the policy has changed does not mean the virtual machine has already changed, because we need to reapply the policy to the VM itself. So when we click on the VM, and we right-click the VM, we need to go to VM policies and say reapply the policy, and then that RAID 1 configuration, which you see over here, is going to change to a RAID 5 configuration. So only then does this happen. It does not happen automatically, magically. You need to reapply the policy. Of course, when we would introduce additional hosts into the environment, so it would move that 6th host into the environment as well, it's going to tell me, hey, you're now using RAID 5, but you can also use RAID 6. Do you want to reapply, or do you want to apply that RAID 6 to your default policy? Do you want to make it go from RAID 5 to RAID 6? So that's what we're going to do in this particular case, just to show you that that also works. We're going to update the policy from RAID 5 to RAID 6. And then I'm going to show you a different way of reapplying the policy as well to your virtual machines. Because what I've just done was reapplying the policy to a single virtual machine. But if you have 500 virtual machines, you don't want to go to every single virtual machine and right click it. So the other thing that you can do is you can go to the policy itself, click reapply, and then have the policy being reapplied to all of your virtual machines at the same time. So if you have 200 virtual machines, it will reapply the policy to those virtual machines, and those grade 5 VMs will now all of a sudden become grade 6, or whatever you want it to be. So that happens automatically. So you as an administrator don't need to vMotion the VM from one data store to the other data store, whatever. That all happens automatically. And then, of course, the other thing that I probably should be discussing is the new snapshotting mechanism. I don't know if people seen long stun times that, when you delete a snapshot at some point in time. At least I've seen it multiple times where you have, for instance, a database which is doing a lot of memory updates. You stun the virtual machine. When you delete the snapshot, it gets stunned, and then for whatever reason, it takes minutes before that snapshot is deleted. That's typically because of the data that we need to move between objects or between files. When you create a snapshot on VMFS, so a regular vSphere data store, or when you create a snapshot on vSAN, we actually create an additional file or an object. And all new I/O is basically redirected to that new file. Now, with vSAN ESA, we've actually implemented a different solution. We no longer create additional files or additional objects, but we create a copy of the metadata scheme itself. And we track which blocks have been updated and which have not been updated. That also means that if we delete the snapshot, we no longer need to move any data around. We can simply make changes to the metadata layer, which is fairly similar to what, for instance, a solution like NetApp does. It's a similar type of scheme from a snapshotting perspective. It also means that from a performance perspective, you won't see the degradation that you've seen in the past. And I don't know if people have actually done any performance testing with snapshots or multiple snapshots. I have. And in the past, they promised me that you would see, like, say, 5% or a 6% reduction. But as soon as I hit like 3 or 4 or 5 snapshots, it would go down to 20%, and then 25%, and then 28%, and then 32%, or whatever it ended up being. With vSAN ESA, that is no longer the case. Let me show you what it actually looks like. So this is my own lab in the US. So this is actually a physical environment. So what I've done is I set up HCI Bench, which is our benchmarking solution. And our benchmarking solution, when you run it, of course, is going to run a particular workload across one or multiple VMs. In this particular case, it's one virtual machine that will run that benchmark on. So it's going to start this benchmark, and it's going to do 70% reads, 30% writes with 4K blocks. I just want to create a benchmark. The important thing here is the number of IOPS, the throughput, and the latency that you actually see up on the screen. Because what we want to see when we create a snapshot is we want to see that that performance stays relatively flat. So we're going to create a snapshot, and then, of course, after we've created it, we'll let it run for a while, and then we'll delete the snapshot as well to see if we see any changes from a performance perspective. As you can see, there was a slight, decrease in performance, but we're talking about single-digit percentages here, maybe 1 or 2%. Also, from a latency perspective, there actually isn't a change, and if you look at the graph is relatively flat. Now, the interesting thing is that when I let the snapshot run, it wasn't just a single snapshot that was running here. I've actually created multiple snapshots in the meanwhile. So we're talking about 6, 7 snapshots instead of 1, without any performance degradation. Of course, also when you delete the snapshots, and we're talking about significant sizes here, multiple gigabytes worth of data, the performance still stays the same. So there is no change in the graph itself. There's no performance degradation during the creation of the snapshot, while we are running on the snapshot, or while we are deleting the snapshot itself. It just remains flat. And this is one of those capabilities which I think in the future will be very useful when, for instance, you want to create multiple copies of a virtual machine for cybersecurity reasons, for instance, or when you want to restore a virtual machine. And that's what I actually want to talk about next, because one of the biggest problems we've seen, at least I've seen in the industry, I don't know, Joe spoke about it, I had to leave halfway down the keynote, but one of the biggest challenges that we've seen are these ransomware attacks. So has actually anyone experienced a ransomware attack? Mm-hmm. Yes. Yeah, just a few people. I can tell you that the other folks that haven't yet either didn't recognize it that they were under attack, or they will be under attack in the upcoming months, unfortunately. It's probably one of the biggest industries at the moment when it comes to IT. And it is something that everyone, unfortunately, at some point in time will face. And in some cases, what we've actually seen is we've seen businesses going down. Like, for instance, this hospital, they actually had to close down the whole facility because of a ransomware attack. And they weren't actually sure that they could bring it back up. Because first of all, they didn't have the funds to pay the attackers. And then secondly, they didn't have the capabilities from an IT perspective to recover that far back to actually bring their systems back up and running. So that was one of the biggest challenges that they had. And a lot of people are facing similar challenges. Now, if you look at the way that you can protect against these different types of scenarios, of course, most people will actually look at creating a backup of some kind. So that typically works. But depending on how long the attack has been ongoing, in some cases it could be months, so it could be dormant for months before you actually see it popping up. If you need to go back 3 months in time and recover from that point in time, it could be quite painful, of course. And then the other option, of course, is replication of data, but then typically when you replicate data, you also replicate the problem. So that doesn't necessarily solve the issue. The other thing is, well, and this may be even a bigger problem, when something like that happens, is you need to be able to actually find all of the different workloads within that backup set or within that replica set, and you need to be capable of recovering those. Then on top of that, if you recover them and they're not completely clean, how you actually clean those virtual machines. So that is another challenge. And then the second challenge that people will have is when you recover those virtual machines or those workloads, where do you recover them to? Because if you were under attack locally and you recover them locally, who says that some of those systems aren't infected still, which may trickle down to the VM that you've just recovered. And this is also something that we've seen. People identify a particular backup, they restore that backup, and then after 4 hours, the backup has also been infected. You're in the same position again. And this is something that has been challenging a lot of CIOs and CTOs, and they're still challenging those people. So, I don't know if people seen this introduction and Explore, but VMware already has a solution in place to actually combat this particular problem. And that solution is called VCDR. Now, with VCDR itself, so a disaster recovery as a service solution, we've implemented additional capabilities for these cyber attacks. So we're actually calling that cyber secure storage. Now, there are a couple of things that we are working on. First and foremost, this is probably something that I should mention, is in the first release, what we'll have working is a solution where you'll have an on-prem vSAN based solution with some kind of snapshot management, and we're using those ESA snapshots, or could be OSA as well, and that will be replicated to VMware Cloud and AWS. Now, I'm specifically saying that that's going to be the case in the first version because I realize there's also a lot of people that do not necessarily want to use VMC. You may want to use Azure, Google, Alibaba, or maybe even one of the 5,000-6,000 cloud vendors that we have throughout the world. So there could be something more locally that you would prefer to use. We're also working on enabling them for a solution like that. Of course, the other option that we're working towards is building something where you could have vSAN locally here, and then vSAN in the second site or something else in the second site. So that's also something that we're working on. But that is to be determined in the future, depending on what customers are asking. Now, the interesting thing with this solution is not the fact that we're replicating data, because that is something that most storage solutions can do. Almost every storage solution can create a snapshot and replicate a snapshot and recover a snapshot. That's not magic, right? So we're capable of doing that as well in the current setup that we have. The interesting part of this solution, in my opinion, is that if for whatever reason your on-prem environment is being attacked, and you've identified that it's being attacked, is how you actually go about recovering this solution itself. So what we've actually built in this particular process is a mechanism that allows you to determine which snapshots most likely are clean. And it actually shows you that in the UI by the graph and by these bars. So the way we actually go about doing that is by actually analyzing the data itself. So we look at the data and look at the change rate of the data, and if there's significant difference from previous days or previous months. If it's different, then it's probably because data was encrypted in some shape or form. The other thing, of course, that what we can do with VMware Cloud and AWS in this particular case is that we can actually recover it into a fully isolated environment. With VMware Cloud and AWS, of course, it comes with NSX. When you recover, we can create a fully isolated environment, which means that if you go through the process of actually scanning those virtual machines, they're all quarantined at that point in time, and you identify some kind of vulnerability, it isn't immediately exposed to the rest of the world. So you can simply just ditch the snapshot and go to the next one. If this one is actually approved for production, then you could, of course, just recover back to on-premises, or you can remain running within VMware Cloud and AWS as well. So you also have that ability, depending on what you want to do. In some cases, you may want to completely clean this up first, scan every single desktop, you name it, make sure that all processes are in place, and then recover back. But this whole process has already been tested and has been used by customers already. So that is already in place. When it will be available is something, by the way, still fully available in terms of GA, something still to be determined, hopefully in the upcoming months. But it's something that we're working on. One of the other things that we're working on from a vSAN perspective is having a different deployment mechanism for vSAN itself. Now today, if I look at vSAN, most of you probably deploy it as a single site. Some of you may do it as a multi-site, and in some cases, may even be some kind of robo solution itself. What we've also seen customers doing is actually sharing capacity across clusters. So with HCI Mesh, within vSAN, you have the ability to actually share capacity between clusters when you need to. So if you have one cluster, for instance, with 50 terabytes of spare capacity and another cluster is running out of capacity, you can mount that data store and simply provision virtual machines on that remote data store, just like a traditional storage solution. Kind of what it looks like. Now, what we're actually implementing, what we're now introducing, is a new solution called vSAN Max. Now, the question typically comes, okay, what is vSAN Max and who is it for? Well, who it's for is basically intended to be used by larger organizations who are planning on doing some kind of petabyte scale vSAN environment. In those cases where we're talking about 500 terabytes, a petabyte, whatever it ends up being, what we've noticed is that the larger that the environment becomes, the more complex it is in terms of sizing and scaling your environment. So for those environments, what we've actually created is the ability to create a storage-only cluster. So they can create a 6 or 7 node cluster, which as pure function has delivering storage to the rest of the VMware estate. So it literally is a vSAN-based storage array, which is exposed to the rest of the world. That's basically the capability that we've created. So that is something that we've introduced in the platform. Now what that looks like, well, it could look like something like this. So you have that vSAN Max cluster, which is only doing vSAN storage. We're not running any virtual machines on this platform. You're not allowed to run virtual machines on that platform. And to that platform, you can have vSphere clusters connected. That could be one cluster, it could be multiple clusters, it could be a 2-node cluster just running Oracle workloads, for instance, for licensing reasons. They could still benefit from vSAN Max in this particular case, and from storage policy-based management. So they can still create those policies which says data needs to be stretched, data does not need to be stretched, I want to have a RAID 6 configuration, etc. So all of those capabilities are also available for customers using vSAN Max. From a sizing and scaling perspective, if you're one of those customers doing more than 500 terabytes, we'll have specific ready node configurations for vSAN Max as well, because we're talking about pretty beefy service with 24 devices, something like that per host. So it's quite significant. Now, I actually created a environment just to show you what that looks like. And the interesting thing here is, because this is probably the most boring demo you will see today, is that it doesn't look any different than the first demo that I've shown you. from a UI perspective, from a management perspective, we have an additional option, vSAN Max, but when I configure it, it looks exactly the same. Nothing has really changed. From a management perspective, it still is vSAN ESA at the back end. From a data service perspective, I still have the same data services available. From a disk perspective, I'm still claiming the same disks. I can still create fault domains, and I can still create a threads cluster. So that's all that it takes to create that vSAN Max cluster. It's a fairly straightforward mechanism. The only thing that has really changed is the fact that now, when I have a vSphere cluster, that vSphere cluster can simply go to vSAN Max and mount that data store. Now, before it mounts the data store, I need to say this is a vSAN compute only cluster. And basically what's going to happen is we're going to run that vSAN process on that host, which is a client process. You don't need to buy a license for that. So everything connected to vSAN Max does not need to have a vSAN license. After the client has been loaded, I can say mount, and then I can click on mount remote data store, and I can select the data store that I want to have mounted. That could be one data store, but that could also be multiple data stores. So if I have two vSAN Max clusters, or I have other vSAN clusters that I want to connect to that vSphere cluster, I can also do that. So I select the data store that I want to mount, click next finish, it's going to do some checks, and then the data store is going to be mounted. So that process is fairly straightforward. Load the client with 1 or 2 clicks, mount the data store with 1 or 2 clicks, and then you can start provisioning virtual machines. That's all that it takes. From a management perspective, so when you manage that vSAN Max data store, as you've seen during the creation, it's exactly the same. You still have storage pools, you still have the same data services, you still have the policies. Nothing has really changed around that. So it's the exact same mechanism. And of course, when a data store is being connected, virtual machines are already automatically going to be created, which are those VCLS virtual machines that you've probably already seen. One other thing that does happen is that the UI slightly changes. You'll see some additional widgets popping up which show the relationship between vSAN Max and vSphere clusters. So if there were multiple, you would see multiple vSphere clusters on the right side that show you the relationship between the data store that you're managing and the compute that's being connected. Other than that, all of the management, whether it's capacity, whether it's performance, it all looks exactly the same. So that is something which is, from a technical perspective, already available. It's just the licensing that hasn't been announced yet. And as you can imagine, that was all part of that whole Broadcom acquisition situation. So hopefully pretty soon, the licensing for vSAN Max will be announced as well. Hopefully with that, in the past 45 minutes or so, I've been able to explain to you, first of all, what vSAN ESA is and how it works. Secondly, what the benefits are of vSAN ESA from a performance perspective. But maybe even more importantly, from a management perspective and an availability standpoint. Because in my opinion, from an availability perspective and efficiency standpoint, I think it's superior to vSAN OSA. So if you're planning on deploying a new solution, I will highly encourage you or recommend you to use vSAN ESA over vSAN OSA. With that, we've reached the end of my session. We're running out of time, but I'm going to be around all day long. If anyone has any questions, feel free to come up and ask them. I may be Dutch, but I'm not that scary, so feel free. Thanks.